Let's look at our first example of using the Quartic algorithm. In this example, we're going to find an angle given a length. Now, I'm going to describe this in words, but don't worry too much if you don't understand this right away, because we will be looking at this in a graphical example just in a moment. Now, the Quartic algorithm is based on the simple child's game of guess a number. So let's say, for example, I said to you, pick a number between 0 and 100, and I had to try and guess that number. Now let's say, for example, the number you thought of was 61.4. Then I can ask the question, is the number you're thinking of greater than 50? And the answer to that is going to be yes. So I can put 50 down here because I know it's at least greater than 50. And then I can pick a number that's halfway between the 50 and 100, which would be the number 75. And I ask again, is the number greater than 75? So in this case here, we'll have 50 plus the 25, so we're now sitting at 75. And if the answer to that is now going to be no, then again I take the halfway point. So the halfway point is going to be half of 25. So half of 25 is the 12.5. So I subtract off the 12.5 and it gives me the 62.5. And I ask, is the number greater than 62.5? And again you'll say no. So what I do is I go to the halfway point again. So the half of the 12.5 is a 6.25. So I subtract off the 6.25 to give me 56.25. And again, I ask, is the number you're thinking of greater than 56.25? And the answer is going to be yes. So what we'll have to do is add on half of the previous number, 6.25. So I add on now the 3.125 and I get this final number here. So you can see here that we're gradually getting closer to 61.4. And we do it just by adding on or subtracting off the numbers which represent the halfway point. So for example, 50 is a halfway point between 0 and 100. And then we're adding on the 25, which gives us the 75, which again would be the halfway point between the 50 and 100, and so on and so forth. So the Quartic algorithm is just like the simple game of guess a number. Now in the first example of the Quartic algorithm, we're going to be given the x and y coordinates of a point on a circle, and we're going to be asked to find the angle. So what we do is we rotate the point by a known angle using a rotation matrix, and then we ask if the y coordinate is positive or negative. Then what we do is we rotate the point either clockwise or anti-clockwise, dependent on whether the y coordinate is positive or negative, and we keep doing that until the y coordinate tends to 0. Now in the end, whenever we add up our angles the same way we added up our numbers here, it's going to tend towards the hidden angle. So let's go ahead and we'll look at an example of this in the graphical calculator, and then we'll come back and we'll write down some of the mathematics. So we have a circle in blue and we have a phasor in pink. Now I'm going to rotate this phasor to a particular angle. Now we have to try and work out what this angle is, and the only information we're given is the x and the y coordinates of the point on the circle. So we're going to use our simple guess a number. Now this angle here could have been in any one of these four quadrants, 1, 2, 3 or 4, but we're going to start off assuming that the angle is in the first quadrant. That is, it's an angle between 0 and 90 degrees. So what we can do is we can subtract off a value of 45. Now 45 is halfway between the 0 and 90. So if we were to subtract off a value of 45, then we would get to this point here. Now we're able to subtract that off because we know how to use the rotation matrix. And then we ask the question, is the y-coordinate positive or negative? Now in this instance here, the y-coordinate is going negative. So what we do in that case then is we add on half the angle again. So we're going to add on half of the 45, which is the 22.5. And then we ask the same question, is the y-coordinate positive or negative? Now in this instance here, the y-coordinate is positive. So therefore, we're going to subtract off half the value again, which is half of 22.5, which is minus its 11.25. So we subtract that off. Now we're going to continue doing this until eventually the y-coordinate tends towards 0. So again, we ask the question, is it negative? So in this, or positive. In this case it's negative, so we've got to add on half the value again, which would be 5.625. Now we continue doing this and we continue asking whether the values are positive or negative, and we add on half of the previous angle. And you can see if I will continue doing this, we get closer and closer to the point where the value for our y is tending towards 0. And I'll work through the final one now. And you can see here, as we work through this, the value for our y-coordinate here is tending towards 0. Now in each case, if we add up and subtract off the angles, we're going to get the hidden angle. So let's go ahead and we'll add and subtract those numbers. So now we're going to add and subtract the angles. We started off with subtracting off 45 degrees, and then we added on half of it, which is the 22.5, and then subtracted off half of it again, which is the 11.25, and so on and so forth for all of the 9 iterations. Now whenever we add all of these together, we're going to get the angle minus 29.4. Now we can see the actual angle is a positive angle, and we've got an answer here which is negative, but don't worry about that for the moment. We'll cover this when we actually do the algorithm in detail. So what you can see here is that the actual angle we've got here is the angle theta, which is 30 degrees. But how do we get that angle? Well, we put in two values. We put in the y value and the x value. So if we put in the y value for this triangle here, that's going to be the y value there. So that's going to be the opposite, because it's opposite the angle. And we're going to have the adjacent here, which is going to be the x value. So we're going to have an opposite over an adjacent. So what we have here is a tan function. But in this tan function, we're going from length to angle. So what we'll have is an inverse tan, or as we're calling it, an arctan. So what we worked out is the arctan of y upon x. So that's an arctan of 0.5 upon 0.866, and the answer to that is 30 degrees. So in effect, we've worked out a method of generating the first function here, which is the inverse tan function. Now the Quartic algorithm doesn't work exactly like this, but we're going to go into more details of the actual algorithm over the next few videos. So thank you for listening. I'll get you on the next video. Goodbye.